This video is to help you understand how to find average speed. I apologize, I've been sick, but I really wanted to get this video up and going. This average speed example, I have two problems that we'll work through just to kind of get familiar with the rate, distance, and time formulas. So the first question is, suppose that on a round trip, 40 miles each way, you average 40 miles on the way out, then an average of 60 miles per hour on the way back. What is your average speed for the entire trip? Really tempting to just add those two together and divide by 2, right? 40 plus 60 gives you 100, divide by 2, 50 miles an hour, right? No. Speed is distance over time, so we need to find the total distance and divide it by the total time to find the average speed for the whole entire trip. So because I'm a visual learner, I went ahead and made kind of a graphic so that we can kind of break it down just a little bit. So here I have my very old classic car, and I know it would never reach 40 and 60 miles per hour, but it was cute. So here we have the total distance there is 40 miles and then 40 miles back. And so we have both trips there and back. On the way there, we know that we average 40 miles an hour. On the way back, we were told we average 60 miles per hour. Okay, so now I need the average speed. How do I find speed again? That's a rate, and we were given a formula for rate. Rate is, oops, I don't have it there. Let's put it down. Rate is distance over time. So I need a total distance divided by the total time. Well, I can easily find the total distance. I was told 40 miles an hour. So all I need to do is 40 miles there, 40 miles back, and I have a total distance of 80 miles. That was fast. Now I need to find the total time. It's a little harder. So I need to find the total time it takes to get there and the total time back. Well, if rate is distance over time, then I can rewrite this equation as time equals distance over rate. The way I did that was solving this equation by multiplying both sides by time. By time. Over here, the time would cancel out. Here, it would not cancel out, but I want to get rid of the rate, move it to the other side. So I would divide both sides now by rate. And then the rates cancel on this side, and I'm left with time equals distance over rate. So that's how I did that on this, and I'm going to go ahead and get our rate formula back up here. Okay, so now we have the time formula. I need distance over rate. Well, that's perfect. I have distance, I have rate there, I have distance and rate back. So all I need to do is find the time it took to get there and the time it took back. Okay, so the first thing I'm going to do is 40 miles an hour, the time, and divide it by the rate, or the miles, sorry, distance, right here, is 40 miles, divided by rate, which is 40 miles per hour. That gives me a complex fraction, or a fraction within a fraction. So instead of dividing fractions, I'm going to multiply by the reciprocal. So I'm going to take 40 miles per 1 hour, and here I'm going to put 1 hour over 40 miles. Some of you, okay, sorry about that. Okay, so some of you may want to just say, hey, that is the unit conversions, and I have 40 miles on top, I have miles on bottom, the miles will cancel, and I want to replace it with hours, and I have the unit conversion of 40 miles per 1 hour. It's up to you whichever way you want to think about it. Either way, the miles do cancel out, so I can show that by coming up to my strikeout feature here, and I can strike out my miles here. In fact, actually the 40 will cancel out as well, so let's go ahead, cancel out the 40, which leaves me with 1 hour, which I already have written over here so that we were good to go. Now here, on the way back, I didn't go 40 miles an hour, I did 60 miles an hour. So again, I can think of it as two different ways. I can go to the time formula, which is distance over rate, and then think I'm not going to divide fractions, I'm going to multiply by the reciprocal, or you can think of it as a unit conversion. Either way, I have 1 hour to 60 miles. Again, the miles are going to cancel out. But now I have 40 times 1, which is 40, over 60. So I need to calculate 40 divided by 60. Now the reason I broke my screen up like this is I brought Excel over here and I can just use it like a calculator. Some of you are going to continue using your calculators in your hand. That's fine. However, I think this is a lot more convenient, plus it's a lot more accurate, and you can go back and see if you typed something in wrong. Those of you using a scientific calculator can't. Graphing calculators, you can go back and look. So it's up to you, but I also like getting you used to Excel. So I'm going to press equals to make it calculate like a calculator. And I want 40 divided by 60. Press enter, and there we go. 0.6667, or we can think of 2/3, same difference. Okay, so now I have the time it took to get there, the time it took back, and the total distance. So now I have all of the pieces to make my average for the entire trip. I already have my 80 miles. I'm going to go ahead and round this to 0.67. If you don't like that, it's up to you. You can go ahead and put a couple more sixes in. Okay, so now I have distance, time, and time. All I have to do is add those times up, divide the total distance by the total time, gives me the average for the entire trip. So here I have it already up and going. 80 miles per hour divided by 1 plus 0.6. And if you want a couple more in there, that's great. You could keep going, because the rule of thumb with rounding is just don't round until the very end. Here, I could go ahead and make that the fraction 2/3. It's up to you. But if I leave it up in Excel, it will give me a very accurate calculation because I already have it. So I have 80 divided by 1.66667. So I'm going to come over here and use Excel again. And I want it to calculate like a calculator, so I'm going to put equals. And then I'm going to type in 80 divided by, now I could just put in 1.66667. Or if I want it to be extremely accurate, I can do a cell reference. So I want to add parentheses 1 plus, because that's all going to be on the bottom. And I could put in 0.6667. However, if I click on this one, just one left click, it will take that exact calculation. So I'm actually not rounding because I'm doing the cell reference. Close my parenthesis, press enter, and there we go. And because this one was from my old example, I'm going to delete that, and there we go. We have 48 miles per hour for the entire trip. And I'm going to put over here, that 50 was from a different example. I was working this out, trying to make it look nice. There we go. Okay, let's try another example. So I'm going to scroll down to this one, our second example. Suppose that you have a goal to drive 6 miles at an average rate of 30 miles per hour. During the first 3 miles, you travel a rate of 40 miles an hour. How fast would you need to travel during the second 3 miles in order to reach a goal of 30 miles per hour for the entire total 6-mile distance? And again, reminder, distance is rate divided by time. Or rate is distance divided by time, sorry. I was thinking of something else. Okay, so again, it's really, really tempting just to add those two together and divide, right? No, again, we need to find everything possible. And this one's broken up into 2, but they did give us the total. And so that was kind of nice. And remember, rate is distance over time. And again, since I'm visual, I had to create my little graphic here. So I broke down everything they gave us. They told me they were traveling 6 miles, and for the first 3 miles, we're traveling at a rate of 40 miles per hour. For the second 3 miles, we don't know the rate, but we do want a total average rate of 30 miles per hour. Okay, so as we just take in the picture and look at it, I've put in all of the givens. We need to decide what we need to answer the question. So let's just kind of look at it. We have 40 miles an hour for the first 3 miles. So I have rate and I have distance. Again, for the total trip, I have rate and distance. Here I'm missing rate, but I do have distance. So here I need for rate miles over hours, but I have miles. So the only thing I'm missing is the time it takes for the second half of the trip. Okay, so let's think about my formulas again. If I have rate equals distance over time, and we already solved before, time is distance over rate. Well, that's lucky. Here I have distance and rate. Here I have distance, I don't have rate. But I have the distance and rate for the entire trip. So I could find the time it takes for the entire trip and the time it takes for the first half. That means if I subtract those, I'll have the time it takes for the second half, and then I would have the miles, which is 3, and the time it takes. That would give me rate. Okay, so now I just need to start finding some times and subtract those. So I'm going to find the time for the whole trip first, and then find the time for the first half, and then I'll subtract and be good. So I'm going to bring this up a little bit. So for the entire trip, it's 6 miles, and I want the average of 30 miles an hour. Again, just like we did on the first example, I could take the distance divided by the rate here, 6 miles over 30 miles an hour, or you can think of the unit conversion and do 1 hour over 30 miles. Either way, the miles will cancel and I'm left with hours, which is 0.2 hours. Some of you are thinking, that doesn't make a lot of sense to me, this 0.2 hours. So I could change that and multiply it by 60 minutes, which gives me 12 minutes. However, it makes sense that way. We don't want to use the 12 minutes, and I'll explain that in just a minute. So for this first half of the trip, we're going to find out how much time it took there. I'm very sorry that my voice is so hoarse. So we have 3 miles. Divide that by, again, remember distance over rate, 40 miles an hour, or we can think of it as 1 hour over 40 miles, gives me 0.075 hours. And again, if you times it by 60, you'll kind of see that it's 4.5 minutes. That gives me the tools I need to find how much is left of the trip, how much time I have to work with. So I have 0.2, subtract 0.075 gives me 1.125 hours left, or 7.5 minutes. Now the reason I'm going to keep the 1.2 or the 0.125 is we're working with a rate in miles per hour. This might be a little bit more easy to kind of visualize what's going on, but I need to keep the hours consistent with miles per hour. So I'm not going to use this one, I'm going to use the 0.125. So we're looking for miles per hour. I have 3 miles. I now know I have 0.125 hours. There we go. That's all I needed. So I'm going to do 3 miles divided by 0.125 hours. And I'm going to come over here. Oh, by the way, again, to find these, I could have just used Excel. 3 miles divided by 40 miles per hour gives me the 0.075. And I could have done my equals because I wanted to calculate 6 miles divided by 30 miles an hour gives me 0.2, and then I can subtract those by equaling this subtract, and we get the time that's left. Then I'm going to press equals again to finish calculating. 3 miles divided by, and again I can type in 0.125, or I can cell reference, so just left click once, press enter, and it calculates. I need 24 miles per hour. And we highlight this as my answer, so it's easy to find, and I already had that over here just as a reminder. And there we go. We found the answer for the second half of 24 miles per hour. Okay, good luck on your homework, everyone.